Vanakkam. Welcome to this course on biomedical instrumentation. In the past set of videos, we looked at EMG. Before that, we looked at EEG. In the previous week, we looked at ECG. In this video, we compare the three major modalities of bioelectric signal measurement, the ECG, EEG and EMG, and we compare the amplifier requirements and bandwidth requirements of ECG, EEG and EMG. What is ECG? Electrocardiogram. What is EEG? Electroencephalogram. Cardio means heart, encephalo means brain, myo means muscle. So, essentially you are interested in ECG you are interested in measuring the electrical activity of the heart. In EEG you are interested in studying the electrical activity of the brain or the cerebral cortex. Encephalo means in this case cerebral cortex. In EMG you are interested in studying the electrical activity of the skeletal muscles. By the way, the heart is also a muscle, which is a cardiac muscle. Typical amplitudes of ECG is between 0.5 and 5 millivolts, whereas for EEG it is much lower, about 1000 times weaker than ECG at 10 to 100 microvolts, whereas EMG typically is between 50 microvolts to 5 millivolts. The frequency ranges of ECG is between 0.05 hertz to 100 hertz. So, that means there are substantial low frequency components. Also in EEG you find substantial low frequency components between 0.5 and 100 hertz, classified into typical waveforms alpha, beta, gamma, theta, delta, etc. Whereas in EMG the signals start at 20 hertz and can go up to 500 hertz. In some cases, in some rare cases for some specific muscles can go up to 2000 hertz. This is a regular and rhythmic pattern having that typical PQRST wave that keeps on every time the heart beats you have a PQRST pattern. EEG is also rhythmic, but looks more like noise, low amplitude oscillations that appear noisy. Whereas EMG is irregular bursts depending on the muscle activity. When the muscle is active, there is EMG. When the muscle is not active, that is baseline EMG. Not that the EMG is 0, that is baseline EMG. But the clinical use of ECG to detect arrhythmias, we looked at that. We looked at how to use ECG for that. Also, we looked at valvular pathophysiologies, for example, stenosis, regurgitations, all these things. Heart block, infarction, all these things. Whereas in EEG, we are more interested in assessing epilepsy. Nowadays, people say that they can use this to study thoughts. I mean, you cannot exactly study thoughts. You are studying brain activity. An exact thought cannot be codified, not yet, using EEG. Okay. Study brain dysfunction or brain injuries. Okay. For example, coma, this in EEG. For example, it is also used to study stage of sleep and sleep, how well a person is sleeping, sleep quality, and how to improve sleep of a person. For example, that is another topic that is up and coming. Sleep, using EEG to study sleep is a topic that is up and coming. Then using EEG to build brain computer interfaces is another common topic that is coming up, right. Not just epileptic seizures, but also sleep, but also a brain computer interface, but also we can also use this to study the depth of anesthesia, for example. It is a challenging problem. Then EMG can be used to study muscle disorders or nerve injuries, or using nerve conduction studies we can study whether the person has demyelination disorder or some muscle disorder, or it can be used to study in research how activity is related to muscle activity is related to particular task that is being performed, or fatigue, for example. ECG typically has bandwidth between 0.05 and 150 hertz. So, because we are interested in capturing the low frequency components like PQRST waves, EEG typically has bandwidth from 0.5 and 100 hertz, detect brain waves. What are the waves? We saw that alpha, beta, gamma, theta and delta. the various rhythms of the brain. EMG bandwidth is between 10 and 2000 hertz, or typically more. This needs high bandwidth for fast contractions, for detecting fast or rapid contractions of the muscles. So, ECG amplifiers emphasize low frequency fidelity to accurately capture slow moving or slowly changing cardiac signals like PQRST. EEG amplifiers are optimized for low voltage and slow brain activity, requiring excellent noise filtering. For EEG you need excellent noise characteristics, and EMG amplifiers essentially require a wide bandwidth between 10 and 2000 hertz to detect rapidly changing muscle activity or fast variable muscle spikes, often that are found in noisy environments. So, with this we come to the end of this video comparing ECG, EEG and EMG. What is a common requirement of an amplification system between these? Well, typically we want CMRR above 80 dB, typically that is a common requirement, for example, and electrode impedance varies actually. Impedance must be below 5 kilo ohm for which one? For ECG, right. For EEG it is below 10 kilo ohm and below I think 20 kilo ohm for EMG. Okay. What is up and coming improvements that are there? You know, use of machine learning for classification, use of AI and machine learning in classification of these signals is an up and coming field, common to all the things. Improved electrodes, those that use PEDOT PSS, conductive polymer type electrodes is common. There is wireless systems, wearable systems, and dry electrodes is another commonly up and coming development in this field. Remember, in all these cases system design is essentially dictated by the signal quality and the signal constraints. Remember, between ECG and EEG there is a 1000-fold difference in the signal amplitude. So, system design, the amplifier design must essentially consider this difference, right. So, system design is dictated by the signal strength and signal quality and noise characteristics. With this we come to the end of this video. Thank you very much for your attention. With this I think we are also ending the 7th week content. Thank you very much for your attention. In the next week we will look at other things, other EXGs, I think ERG, EOG, and then the other topics like galvanic skin resistance, phonocardiogram, all these things have been left out from this week's content. These things we will teach in week 8. Okay. Thank you very much for your attention.